Hi, my name is David Sharp, and this is the project presentation for EEL6562 Fall 2012 Course Project. The project title is Exploration and Improvements to Transform-Based Image Coding. The problem under study is the JPEG codec. My goals here are to gain a greater understanding of the JPEG codec, as well as a greater understanding of source coding in general. The improvement that I propose is an improvement to the JPEG codec I named Edge Adaptive JPEG Codec. Another area explored by this project, mostly just for fun and for my own curiosity, was something I'm calling Triangular Mask JPEG Codec. The existing approach is the standard JPEG codec. An overview is the input image is divided into 8x8 blocks, the DCT is performed on each block, the resulting coefficients are quantized by matrix Q, and then entropy coded. The decoding process, the entropy decoding occurs, then the dequantization by Q occurs, and then an inverse DCT yields the decoded image. Why use quantization? Higher frequency coefficients contain less energy and therefore often less meaningful data. If we remove the insignificant coefficients prior to entropy encoding, we generate long zero runs, which aids in compression during the run length encoding. The disadvantage of this process is information loss. The advantage is that we increase compression, and the artifacts that are incurred are often unperceivable to the human visual system. In standard JPEG, the quantization matrix is constant for the entire image. Lower JPEG quality levels can be used to increase the quantization step size. When this occurs, more of the high-frequency content is lost. Elimination of this high-frequency content increases compression, but also increases distortion in the reconstructed image and decreases subjective quality. Some related work to the edge adaptive method is Pan in 2002 used DCT coefficients to classify blocks in the image. He ended up with 4 classes of blocks. The types were non-edge, horizontal edge, vertical edge, and diagonal edge. He required a unique zigzag pattern for each block class. Then in 2007, Yu, Chang, and Hu also did a method similar to Pan but used a hue transform as their block classifier. Again, they required 4 block classes and 3 zigzag patterns. My first proposed improvement is the triangular mask JPEG codec. My goal here was to simplify the quantization stage. Essentially, the DCT would be performed, and then a mask of the DCT coefficients would be performed. The mask is shown below, where 3 of the 64 coefficients are 1 and the remaining are 0. Essentially what would happen is we would discard a fixed number of coefficients prior to the entropy encoding stage based on the mask. In this case, the number of coefficients discarded would be 61 of the 64. Then the entropy decoded coefficients would be padded with zeros to restore the original 8x8 block size. Using the example shown, if we keep 3 of the 64 coefficients, then the resulting image size should be about 4.7% of the original size, at a minimum. For the edge adaptive JPEG method, we used a basis of the standard JPEG algorithm. Then we used an edge detected image. We classify the 8x8 blocks in the image as high or low edge content. Then we adapt the quantization step size to the edge content. For my implementation, I'll use 2 quantization levels based on the block classification as either high edge content or low edge content. For the edge detection, we use a canny edge detector. Here is the Lena image shown in the original image, and then to the right, the edge detected image. MATLAB was then used to draw a box around each 8x8 block that contained edge pixels of less than 5%. As you can see, the blocks with edge pixels of less than 5% were numerous. Then the same process was done for edge content of greater than 5%. As you can see, the number of blocks shown in this image is much less than the one shown in the previous image. A numerical analysis was done to show that there's 57.15% of the 8x8 blocks in the image that are less than 5% edge pixels, and therefore the majority of the image for the Lena image is low edge content. Here are plots of the individual block DCT coefficients for a a block with very high edge content, and a block with very low edge content. The plot on the left shows a block for high edge content, and the plot on the right shows a block with low edge content. As you can see, the coefficient magnitudes are much larger for the high edge content versus the low edge content. For the edge adaptive JPEG method, the minuscule coefficients in the low edge blocks should allow us to reduce the size of those blocks without negatively affecting image reconstruction. We'll do this by increased quantization step size for the low edge content blocks. The desired effect will be a reduction in encoded image size without reducing PSNR, or an increase in PSNR for a given bitrate. The implementation of the edge adaptive method started with an edge detected image. Then the 8x8 blocks in the image were classified as either high or low edge content. For this implementation, a threshold of 5% was used to define the difference between high or low edge content. Then we encode the image using a standard JPEG algorithm. With the exception of the low edge content blocks, the quantization matrix elements would be doubled to thereby give greater quantization step size for those blocks. The drawback of this implementation is the decoder requires knowledge of the block classifiers. To do this, we have to store this information in the encoded image. Since the classifiers are only a binary 0 or 1, we only require 1 bit for each block classifier. For a 512 by 512 pixel image, that results in an additional 4096 bits in the encoded image. Evaluation of the performance of the triangular mask codec. For this method, we used a baseline of standard JPEG at 10% quality. The table on top shows the resulting encoded image sizes for both methods. As you can see, the triangular method performed worse than the standard method on certain images, but then on other images, such as the baboon, it performed much better. The table below shows the PSNR values for the standard and triangular methods. Both the PSNR values were close to equivalent, although there were some minor differences between each method. Here's some example images shown from both methods. As you can see, the things to note are the standard JPEG image shows many blocking artifacts on the wall behind Lena and on her arm. The triangular mask method does not show many of these artifacts like the other method. However, the edges in the triangular mask method are greatly blurred and distorted, whereas they're relatively sharp in the Lena image using standard JPEG method. Another good example for the triangular mask codec was the baboon image. In the standard image, the hair lines on the sides of the face of the baboon are very clear and still crisp, whereas in the triangular mask method, they're blurred significantly. For the edge adaptive codec, we started with a baseline standard JPEG at 50% quality. The first table shows the encoded image sizes for both methods. The second table shows the PSNR values for both methods. This table shows the cost savings for the edge adaptive method. As you can see, the bit savings incurred by the edge adaptive method were on average around 20,000 bits, which is a significant increase over the standard JPEG method. The PSNR reduction using the edge adaptive method was always less than 1 dB and often very small. Even for the baboon image, where the bit savings was only 6,600 bits, we still were able to increase the bit savings greater than the 4,096 bits required for storing the block class. This shows a plot of PSNR versus bits per pixel for the standard and edge adaptive methods. As you can see, the edge adaptive method consistently outperformed the standard method. In conclusion, the triangular mask codec did not perform well at all. It was not practical for general use and was not constantly able to decrease file size versus the standard JPEG method. There was significant distortion to the image edges, and the implementation created a low-pass filter effect on the decoded images. Artifacts for the triangular mask included the reduction of blocking effects, but an increase in blurred edges and loss of fine details. The edge adaptive codec was a great improvement over standard JPEG. He was consistently able to decrease the file size over standard JPEG with minimal reduction in PSNR. There was significant bit savings for images with low edge content, such as Lena, and although there was less bit savings for images with high edge content, such as the baboon, they were still able to perform better than standard JPEG. And now for a demonstration of the computer programs, go to MATLAB, and I'll start with the triangular mask method. The triangular mask method displays the original image and then displays the image with standard JPEG, followed by the image with triangular mask method. For this example, I'm using the baboon image. Now for the edge adaptive method. The edge adaptive implementation shows the original image, uh, the edge detected image of Lena, the plotting of the high edge content blocks, the plotting of the low edge content blocks, the DCT AC coefficients for blocks with high edge content, the DCT AC coefficients for a block with low edge content, the decoded image using the standard JPEG method, and the decoded image using the adaptive JPEG method. In addition, on the command window, we have various outputs for both methods and some comparison metrics. That concludes my presentation. Thank you.